Hi guys, in this question we've been asked to draw a dots and cross diagram for H2F positive ion. Now both of them are non-metals, so it must be a covalent bond. However, it's a positive ion which represents something unusual, and that unusual thing is that, well, one of the ions it has to be a positive ion or electron deficient. So it can't be fluorine, okay, because it's the most electronegative atom in the whole periodic table, so it must be one of the hydrogens. So if we start by drawing the actual structure of HF molecule, which is just a simple covalent compound, okay, so let's just draw that out. 7 electrons on fluorine and 1 on hydrogen. So it's forming a single covalent bond. Now, because fluorine over here is electron rich, okay, it would end up basically sharing one of its pairs of electrons with another hydrogen, but that hydrogen must be an ion, okay, meaning it must be deficient in the electrons. It's just a nucleus of a hydrogen atom. So if it ends up forming a covalent bond with the hydrogen ion, it will end up basically donating, well, one of its pairs, or rather sharing one of its pairs, to form a dative bond. So we can use another dots and cross diagram. So the first just remains as normal, okay, and the second hydrogen now will share electrons with the fluorine, okay, and that's the first hydrogen, and so it's forming a single covalent bond. However, the difference is that fluorine is providing both the electrons, and we show that using an arrow, otherwise there's no way of showing or knowing whether it's a covalent compound or a coordinate dative bond, covalent dative bond involved. So of course, because fluorine over here is sharing its electrons, we'll put a positive charge on fluorine, and this is it. Okay, this is how you'd show the bonding between H2F positive ion. Let's move on to our next question, which is definitely a good one. So in this question, we are given that the structure of aluminium chloride exists as Al2Cl6 at sublimation temperature 180 degrees C. We have to use dots and cross diagram to show the coordinate or dative covalent bonding in this particular structure. Okay, so Al2Cl6 exists like so, okay, because it's more stable, and initially we would think of AlCl3. Okay, now AlCl3 is just what comes to mind, you know, especially when we're dealing with like GCSE questions. It is simply a covalent compound, and aluminium is, well, aluminium's got 3 electrons. It's very shaky. There we go. So 1, 2, 3, and chlorine has got plenty of electrons, 7 to be precise. 1, 2, 3, 4, 5, 6, and 7. So it is sharing a pair of electrons with aluminium, like so. 1, 2, 3, 4, 5, 6, 7, and the other one as well. Now, in this particular molecule, everything at first looks good. However, if you notice carefully, aluminium only has, well, 1, 2, 3, 4, 5, 6. Okay, 6 electrons in total, which means that it is, well, electron deficient. Okay, delta positive. So that means that it can easily form a dative bond with another of these AlCl3 molecule in such a way that it has now 8 electrons. So you have to think this through before you actually draw this out. Okay, so we are combining here 2 of the same. Okay, so AlCl3, okay, 2 of the same, so that aluminium becomes has a full octate. Okay, so it needs to therefore receive those or share those extra 2 electrons, you know, right here perhaps. So if we try that out, you know, I'm not going to draw any extra electrons, but let's just start off with the first one. Okay, so you've got aluminium with just the normal chlorine bonds. Okay, now what tends to happen is that if you take another aluminium chloride molecule, such that the first aluminium, right, this aluminium receives a pair of electrons. So I'm just going to draw this using another color. So that can only happen if the chlorine of the second molecule, second aluminium chloride, ends up sharing its pairs of electrons, because at the end of the day, chlorine has excess of electrons, so it would end up sharing its electrons. Now, to obviously complete this, we have to think about the second aluminium as well. So if I just draw this out like so. So the second aluminium right here also is electron deficient, just like the first one. So I've put it in such a way that it faces this chlorine. Okay, so this chlorine will end up giving or sharing its pair of electrons with this aluminium, so that it ends up having a full outer shell of electrons. And this is how it ends up forming two dated bonds. And basically it's also called a dimer or dimer, okay, however you guys like to call it. Now, dimer is just a compound which is formed by joining two molecules. So, to write this neatly, I would just represent the dative bonds with the arrow. Okay, so we've got two AlCl3 molecules. Oops, that's supposed to be nothing there. And there we go. So we've got these two molecules combining to form Al2Cl6. Okay, so I hope you guys found this useful. It was a very, very good question, I reckon. So try it later as well and see how you get on. Let me know in the comments below. Thanks ever so much.